got the topic 2.2, standardization is what we're going to do. Before we start, I think you should know a few basic things to make this lesson flow. First off, our group members are Claire, Adrian, and Sarah, and we're in the class third period of Miss Zugero. So change your standard deviation of mu is called standardizing. Once you learn this lesson, it's going to be hypnotizing. The standardized value is called a d-score, which tells you how many deviations and observations your observation falls away from the mean. Is it less? Is it more? Standardizing gives a common scale. Before you know the formula z equals x minus mu divided by standard deviation, you should know that in order to do well. Step 1 is simple. Restate the problem in terms of x. The first step is important. It's key to success. If you don't get this first step, you might trip and fall, and then you'd scrape your knee and cry and bawl and bawl and bawl. So next, draw a picture and shade your area of interest, and don't get distracted and end up on Pinterest. Step 2, here's a clue. Restate in terms of z. Use x minus mu divided by standard deviation, and it'll be easy. X is the statistic and mu is the population. Standard deviation is what we divide by. It's the trend that's sweeping the nation. Step 3, find the required area using table A. Step 4, write down the conclusion, then go hooray. You can find table A in the back of your book, or maybe you can find it on your Kindle, iPad, or Nook. I don't know, but it's important to find. You better look for it. It's not a waste of time. So we went through that fast, so let's back up some and do an example. It'll be so much fun. So let's say Adrian took a test and got a 2.4 out of a 2.400. Let's see if she is our statistical hero. She might be or not. It's sometimes hard to tell. Sometimes her grades are great, and sometimes we find they fell. 1840 was her score. The average was 1560. Tell me one thing more. Standard deviation for the test was 210. Let's compare her score to Claire's and see who wins. So how do we compare when it's out of two different numbers? We want to do this without faulting or blundering. So Claire took a test and scored a 29. This was out of 36. This is how she thrives. The average was 26 and the standard deviation 2.1. Let's plug these numbers in. It'll be so much fun. So Adrian's 1840 is the x. 1560 is her mu. Subtract those numbers and divide by 210 because you know what to do. Our total is 1.33. Our z-score is 0.9082. Do the same for Claire, and her z-score value is value number 2. Her z-score is 0.9236, and listen up closely because the next step is something you do not want to miss. Since both values are now on a common scale, we can take the two scores and compare. Since Claire's score is higher, she really did better. It's probably because she wears those smarty pants sweaters. One more thing that's important to remember, it's the empirical rule that we learned in September. 68, 95, 99.7, they show where our values fall. It's the empirical rule. Okay, we're done. That's all. Be sure to double check your work because you don't want it to seem like you missed something. Can't really think of anything that rhymes with something. So have a lovely day. Z-score. Got 99 problems, but a Z-score ain't one of them.
Slowing it down a bit.
So Adrian took the SAT, which is a test out of 2400, and from that she scored an 1840. That is our X value. The mu is our population parameter, which is 1560, which means the national average on the SAT that round was a 1560. The standard deviation on that test was a 210. So in order to find the z-score, we're going to do x minus mu divided by standard deviation. So we plug in our numbers, and we do 1840 minus 1560 divided by 210. This gives us our z-score, which is 1.33. Then we take our z number, go into table A, and then we find that our p-score is 0.9082. Now we want to compare it to Claire's score. So Claire took the ACT, and that's a test out of 36, of which she scored 29 out of 36. The population average was a 26, and the standard deviation was a 2.1. So from that, we do 29 minus 26, which is our statistic minus the population average, divided by 2.1, our standard deviation. This gives us a z-score of 1.42, and once we plug that into table A, we get a p-score of 0.9236. So once we have both of our p-scores, we want to compare our values, because now the values are standardized. They're based on the same scale, so we can see who truly did better. So Adrian's score is 0.9082 and Claire's is 0.9236, so we can tell that based on that one test, essentially Claire would have done better because her p-score value is higher.